Dear colleagues, welcome to my course presentation. My name is Özgür from retail e-commerce solution provider industry. I would like to talk today about a personalized recommendation engine that's enhancing customer experience in the e-commerce business. So I would like to only cover the parts that's mentioned in the course project because of the time limitation, and I'm going directly to the opportunity evaluation. So to state the problem that we have overwhelmed customers very often due to vast product options in the market, right? So that's a big problem for the users to actually find the products that's relevant to them. So is the opportunity attractive for our solution? We need to evaluate 3 questions for that. So first one is there a problem? Yes, there is a serious problem about customers struggling with the product discovery. So when they need to find relevant products, they have issues in the vast number of products to actually find the ones that they are interested. The next question is, can we use machine learning to help solving this problem? Yes, actually, that's one of the main usage cases of the machine learning because it's a personalized recommendation engine that's going to use algorithms to be able to make these predictions. So then last and the most important question is, does someone care? Yes, actually, we both care from the customer and business perspective. Customers will have a smooth shopping experience and will be more happy with our website or with our commerce service. And the businesses will be happier because then they will increase their sales and they will have more satisfied customers. In the Christian process, let's go to the next step, which is the business understanding. So I would like to start with the problem definition. That's the target user of our application is e-commerce customers. Statement of the problem is difficulty in finding relevant products. So they're having difficulties to find relevant products to them in this vast market. It matters because we would like to enhance the customer satisfaction. And through that, we can be able to actually enhance the sales. Current solutions that we have is like manual curation maybe, or basic filtering through the products, and maybe some very basic recommendations depending on the ratings. But the gaps are, it's lacking a lot of personalization, meaning that there is no personalization, and there is also scalability issues when the product numbers are increasing and categories basic filtering becomes very cumbersome. If we define the success for us, the business impact is we would like to increase the average order value when the customer visits the website. We would like to increase the click-through rate of the customers. And we also want to improve the customer retention rate. So they're coming back to our website for shopping. We would like to increase the retention rate. Defining the metrics, outcome metrics, depending on this business impact, to define it is the first thing is a certain percentage increase in AOV, which is average order value, improvement in the click-through rate, and decrease the churn rate reduction. So the customers that's never coming back. If we define some output metrics, this might be, of course, discussed or defined in a different way when we decide the algorithms also. But the first things that comes to mind is we would like to use maybe a precision for our recommendations, how precise they are. We would like to have a recall. And we can also use here, for example, F1 metric. And we would like to use a root mean squared error for actually seeing how much we are far away from the real purchase. Let's define the relevant factors. The first and the foremost important one is the customer demographics, maybe the age, maybe the location that the customer is living, or the maybe gender of the customer or financial status. And the second one is the personal purchase history. So what actually this customer is buying from our website. The next one is the browsing behavior. So when they are going to the website and going around the website, how they are behaving to find the product. And the next thing is of course, the attributes of the product. So we have different products and their attributes is going to be very important for our engine. Define the solution concept. As I mentioned at the beginning, we would like to have a recommendation engine. Maybe using collaborative filtering. This is about the collaboration to the user's choices and filtering depending on the user purchases or user behaviors, preferences, and also content-based filtering. That's about the product content and the content of the products that we have, filtering depending on that, and maybe hybrid approaches, so combining both. So how we will validate this concept is, as Christian suggests, that we will have iterative experimentations. So the first thing, we will have a prototype development. We might start with a very basic recommendation engine using maybe a simple algorithm or let's say initial collaborative filtering model. We will test this, evaluate the metrics, precision, and recall, and we will also go to the users, get feedback, and refine the model. And then in each iteration, we can also think about incorporating different algorithms, such as maybe content-based features, like the product features, and we can use also different hybrid methods, and we can also use A/B testing, so rolling out this to certain customers in A/B testing to see the results from the different past customers. The most important thing is, of course, the feedback loop, continuous feedback from the customer to refine the model. Let's answer a couple of important machine learning system design decisions. First question is cloud or edge. So the decision in that case would be obviously a cloud-based solution when we consider the scalability of the solution, the maintenance that we need to do for retraining, and also that we are processing large data sets. These are large product catalogs and also large maybe customer data, historical. So processing this is going to be a cloud solution. The next thing is about offline versus online learning. In our case, it would be a combination of both probably, because the first initial model will be trained on the existing data or historical data. So this will be the offline part. However, we need online learning for the real-time updates to the model when the customer purchases a new, for example, product, and we need to retrain our model. Or maybe a new product is added to the catalog, we need to train our model to incorporate this product. So this is going to be a kind of real-time online learning. The last decision is batch or online predictions, and obviously online predictions, because each time that the customer interacts with the website, we would like to personalize the recommendations depending on this new behavior or new purchase or anything that's happening in the real time. So it's going to be online predictions, and batch is not really useful in that case. So after we develop our algorithm model and also application on it and integrate it to our e-commerce website, now we maybe roll it out to the production. So what are the potential risks that we might face? So the first thing is training serving skew. So we are using data maybe to train our model initially from the historical data that we have about the user or about the products also. But the real-time system might have different products, might have also different, for example, user preferences. So there might be different data coming into the system, especially considering the products, for example, changing over time. So we need to be very consistent about pre-processing to mitigate that, to be able to see that all the historical data are still relevant today. And if there are parts that's not relevant, if there is a product that's not there anymore, so we need to be careful about cleaning this data. The next thing that I would like to talk about that happens a lot in this kind of recommendation systems is data drift. So over time, the changes of the customer behavior or the product catalog, for example, will have a data drift in the system. So if there is, 20 new products coming up that didn't exist during the training time, and this will cause a data drift. So we can mitigate that by two things. One of them is that we can make regular model retrainings. That's like a kind of offline training, maybe regularly and scheduled. And also we are using online training. So it means that when there is a new, for example, product is introduced or the purchase of the user, then we can retrain our model online so we can adapt to this data drift. And we can keep monitoring actually to see that if there is a data drift at all. So if we recognize there is a data drift happening that's maybe over a threshold, then we need to be already retraining our model. The next interesting thing about this problem is concept drift. So the relation between the data and the target recommendations that we have might also change. So this can happen due to seasonal effects. For example, summer, winter might affect choices of the customer, right? Or for example, when there is a new trend that is affected by social media or by some famous people that might affect the behaviors of the user, right? So the concept, the relation between these input and output might also drift over time. And how we are going to address this issue is that as the data drift, we need to continuously monitor the performance. So to actually try to find out if there is a concept drift. And also online learning will help this a lot, because when there is online learning introduced, so the algorithm and the model will adapt to these changes much better over the time. So the last but still important is a latency issue. We talked about we would like to have real-time recommendations, right? Online recommendations. So if there are delays in the recommendations, then this will be also affecting the experience of the user. So we need to optimize our model to perform fast. Actually, we can try different models. We can choose the ones that's performing faster, and we can also optimize our infrastructure, cloud infrastructure. We can use Azure or AWS, and then in that cloud structure, we will do our best to optimize it. Thank you very much for listening. There are much more aspects to this project, of course, that I actually prepared or thought about, but the time limitation only allows me to talk about that much. If you have any questions or comments, please let me know. I will be more than happy to connect, and looking forward to your feedback and review. Thank you.